Hello everyone, and thank you for joining us to explore how the insurance industry is uncovering hidden insights using locational intelligence. My name is Alex Martinick, Esri's commercial industry specialist for financial services and insurance. My primary responsibility is managing Esri's strategic initiatives for risk management. And now this encompasses everything from insurance portfolio management to corporate security and business continuity. Over the past 3 years, I've been helping our users from both government agencies and the private sector transform their core operations using location so they can make well-informed decisions. I'm joined here today by Russell Sands, who is a solution engineer for our insurance team. Russell is one of our technical leaders here at Esri, focusing on how GIS can revolutionize traditional workflows in underwriting, risk modeling, and claims. Russell has spent the last year and a half working to shape Esri's geospatial solutions for the insurance industry, and he's joining us today to discuss some of the best practices for visualizing exposure and sharing information throughout an organization. Now, prior to coming to Esri, Russell worked at AIR Worldwide as a GIS specialist. Today, we're going to be discussing a lot of innovative ways the insurance industry has approached risk, and these may feel like new concepts to you. But location serves as a natural lens to understand complex and multidimensional data. And I'm going to take a moment to discuss location in the context of what we've experienced in 2017. It goes without saying that 2017 was a chaotic year to be in the insurance industry. Within a 3-month period, we witnessed several record-breaking events and firsts here in the United States. At the end of August, for example, Hurricane Harvey and its connected events resulted in record rainfall in the continental United States. Within a single day, the storm produced 9 trillion gallons of water, which equates to roughly 60 total inches of rainfall. Now, regardless of the infrastructure that's in place, most areas would struggle to overcome and manage that level of flooding. Not to mention the storm's intensity escalated quicker than observers had initially predicted. Aided by warm pressure systems and elevated sea temperatures, the storm quickly intensified after passing through the Yucatan Peninsula. In fact, Harvey upgraded from a tropical storm to a Category 4 in less than 32 hours, leaving little time for planning before it made landfall. Soon after the significant destruction of Harvey, another hurricane was forming in the Caribbean. Now, learning from Harvey, Hurricane Irma was closely monitored from its early stages, and once the storm was predicted to make landfall in Florida, widespread mandatory evacuations were announced to reduce the casualties. Unlike Harvey, Irma's destructive power came from intense force from sustained winds of over 185 miles an hour. And yes, that is the highest on record thus far. This was classified as a Category 5 at its peak. Thankfully, the storm downgraded before making landfall in Florida, but it was still a Category 4. So 2017 marked the first time 2 Category 4 hurricanes hit the United States within the same year. This increasing intensity of events was not isolated to the Gulf of Mexico and the Caribbean. 2017 experienced catastrophic events across the world on an elevated scale. Here in California, for example, we experienced some of the costliest wildfires in the state's history. The Napa-Sonoma fires in October were the most destructive to property since the Great San Francisco earthquake of 1906. Within a week of the initial reports of fires in Napa, 6 separate events erupted, engulfing 209 square miles, also resulting in the destruction of 3,500 total structures. Entire neighborhoods were engulfed, leading to one first responder reporting, "Things that shouldn't burn are on fire." These events signal that the frequency and intensity of natural disasters are increasing, and not just on a local or regional scale. This is evident by the recorded losses. Now, there are many figures circulating estimating the damages, and they vary in the hundreds of billions. So we're going to be using the Swiss Re Institute's report of natural catastrophes and man-made disasters in 2017 as a basis for this discussion. According to the Swiss Re Institute, there were $144 billion worth of insured losses in 2017, and a total of $337 billion in total economic losses. This is damages plus business disruptions. Although this itself is not a record figure for yearly losses, it reflects this upward trend that we're discussing. And as the insurance industry continues to grow in new and existing markets, it will inevitably become more exposed to these increasing risks. To prevent catastrophic losses, these companies need to understand the risks they face on a deeper level. Oftentimes, though, analysts find it difficult to make sense of the sheer amount of data at their disposal to begin with. Now, I will say in 3 years working within GIS, the insurance industry has a unique, it's an issue of sorts, but that is that it has access to inordinate amounts of data and sources, from historic perils and disaster models to current policy information and real-time weather feeds. Oftentimes the greatest challenge in risk management is integrating these disparate systems and deriving actionable insights, finding the signals within the noise. Risk analysts, they need a way to quickly separate this relevant information and clearly communicate results with their stakeholders. What's the value of being right if you're unable to communicate that clearly and have a decision maker make a decision based on that point? To do this effectively, analysts need more than just raw computational power. They need a way to derive deeper contextual understanding to support critical business decisions. Context leads to clarity. To achieve these goals, the insurance industry must find and understand what connects policies and risks. Right now, several companies are utilizing location intelligence to refine methods for point-based risk scoring, for example. That's where we look at the relative exposure of a policy based on the risks around it, not just relying on its inclusion within a zone. And this is becoming increasingly important as we look at severe flooding in areas that are outside 100-year flood zone plains, especially within California, where flood risk is now a growing concern. These types of initiatives lead to better decisions for pricing strategies and ultimately result in better portfolio management. But how do we get there? How do organizations go from being overwhelmed by data to these innovative practices and transforming their core functions? It's finding that common denominator, which is location. This is because of the spatial connection between policies and perils. It may seem common sense to say this, but every policy is located at a specific point, and every peril takes place at a particular point in time. Location intelligence empowers analysts to understand this and quickly extrapolate meaningful information and share those insights throughout their organization to shape workflows and strategies. This context leads to more accurate and actionable insights to drive strategic initiatives and transform those core functions. For today, though, let's stick to the basics. Let's stick to the power of location to derive new insights for data that's hidden within spreadsheets, for example, or policy databases. We know that this data comes from many sources, and your organization may not have a centralized database. So how do we integrate all of these feeds and derive value and quickly share that information for those key stakeholders and cross-functional teams? Now, I'm sure many of you have attended webinars and conferences before, and you're used to seeing demonstrations where the presenter highlights an end view or finished product without discussing the work needed to create that solution, or the limitations and the inflexibility of some of them. We're going to do things a little differently today. We're going to show you the behind-the-scenes view and the basic steps needed to quickly visualize your data, securely publish the results throughout your organization, and then stand up a viable information product for decision makers. All this we're going to do in the next 25 minutes without coding. Our goal is to show you that despite your background or technical skills, these highly effective solutions can be available to you now. If you are watching this recording or attending this webinar, you already have the technical skills to do some of these innovative solutions. As we're presenting, please pay attention to these three components. First, the power of using location to understand insights that are hidden within your policy databases and spreadsheets. Next, the value of quickly sharing that information within your organization and leveraging the knowledge and expertise of your analysts. And third, the level of configurability within these tools that enable you to do whatever you need to achieve your goals, even when situations change. So with that, Russell, I'm going to hand it over to you to get us started today.
Okay. Thank you, Alex, and hello, everyone. I'm happy to be here today, and what I'll be showing to you is really an illustration of how insurance companies are able to leverage location intelligence to move beyond spreadsheets, tables, reports, and charts, and to drive actionable insights. I'm going to get started shortly, but I just want to reiterate a few things that Alex had mentioned. Firstly, data really doesn't have any value unless we use it to support decision-making. And we can't support decision-making without providing context. For many of our stakeholders, though, they don't have a lot of time to read through lengthy reports or to flip through figure after figure in order to find that context. By leveraging location, we're able to create a lens that better enables us to communicate the insights in our data. Today, I'm going to be taking on the role of an analyst who's been asked to identify policies in Texas and Louisiana, where we're concerned about the upcoming hurricane season. I need to be able to share that information securely within our team and to do so in a way that makes the patterns in our data clear. I'm going to be working in ArcGIS Pro in a project that I've called Gulf Coast Policies. ArcGIS Pro organizes my work into projects, and these projects are a collection of one or more 2D and 3D maps, data and databases, analytics, and visualizations. Front and center here is a map, and the first thing that I want to do is select a base map that's going to make my data stand out a bit more. So by using our base map selector, I'm going to choose the light gray canvas. One of the things that we see in the insurance industry is that the data that needs to be incorporated into an analysis, whether it's policy information, hazard layers, territory boundaries, tables, or more, as Alex said, oftentimes this data exists in a variety of different formats, from relational databases to CSVs or Excel spreadsheets. And in ArcGIS Pro, I have a lot of options to enable me to connect to different kinds of data. I can add data using this Add Data button, which presents me with a variety of ways to connect to the data depending on where it lives. I'm also able to use the catalog pane to connect to an individual database or access content that's hosted in our portal. And the portal is a concept that we're going to discuss shortly. For now, I'm going to work with a database that I've already connected that contains my policy data for the United States. I can drag and drop this information onto the map, and I'm immediately able to begin exploring it. I can do this in familiar ways, like looking at the tabular information that's associated with these policies, or I could add some charts directly here in Pro. But the real main front and focused element here is the map. And right now you might be wondering about the nature of your own data. For example, you might have address information rather than the latitude and longitude coordinates of each of your policies. But in ArcGIS Pro, this isn't a problem because we can take advantage of the Esri World geocoding services in order to locate policies based on their street address. We're going to cover geocoding in an upcoming webinar. So for today, we're going to focus in on our data. Like I said at the beginning, in this case, what I want to do is filter all of this data down to only show the policies that are in Texas or Louisiana. I can access my layer's properties and set up a definition query. This enables me to write a SQL command to filter my data or directly use the interface to create my query. So I'll add a new filter that will return only the states that have the values of Louisiana or Texas. Once I have this query set up, I'm able to do some additional things here. I can update the query, or I can verify the query to make sure that it's a valid expression. I could also inspect the SQL so that I could take this query and utilize it somewhere else. Once I hit OK, the query is immediately applied to my data and the map filters. I can then zoom in close to get a closer view of what's happening in these two states. But the thing that's probably immediately apparent is that even when I turn off this light gray reference layer, what I'm still seeing is just large blobs of points that are located around the large urban areas. I'm not really able to discern what exactly the pattern is that's occurring within my data. And it's that pattern that I need to enable other individuals in my organization to drive meaningful insights. So I need to do better than this. And I can do that by creating an aggregation in ArcGIS Pro. When I aggregate my data, this is a concept that you might be familiar with when it comes to aggregating data by political boundaries like zip codes or counties or states. You also may have explored your aggregated risk within specific territories that you've defined. And in these cases, we either sum up or count all of the values for a particular financial term that we might be interested in for all of the policies in our area of interest. And we probably interact with that result as a table. However, if you were to map those areas, it would be pretty immediately apparent that the size of different zip codes or different states and counties and even territories can vary pretty widely. That means that it's pretty hard to look at accumulation results to political boundaries in a way that really compares apples to apples. If we were comparing Rhode Island to California, or even in this case, Louisiana to Texas, it would be pretty hard to compare the aggregate information without further modifying our data. In ArcGIS Pro, we can use our analysis tools to mitigate this problem. I'm going to use a tool called Generate Tessellation. And this is probably a term that is unfamiliar with you, but if you've ever looked at a histogram or a bar chart, the concept should be pretty similar. When we create a histogram, what we do is set up boundaries in our data and aggregate or sum the values that are between the minimum and maximum bounds. A tessellation applies the same concept geographically. So for example, we might set up an even grid and find all of the policies within each square, then aggregate or sum up the values for each policy within each square and map those results. An even more efficient way to create a tessellation is to use hexagons. And hexagons are nice in a lot of ways, but a major point is that all of the policies inside each hexagon that I'll create are going to end up being relatively evenly distributed around the center of the hexagon. In ArcGIS Pro, I have the option to do either squares or hexagons, and I can also create triangles, but I'm going to stick with hexagons, and I'm going to set them to be 75 square miles in size. I'm also going to limit the area that I draw these hexagons to just the area that I'm viewing currently. Once this tool is complete, I'm going to have a map that has all of my hexagon boundaries drawn uniformly across it. But I'm still going to need to perform the second step, which is to summarize up all of the policies that are in each hexagon. If this was a task that I needed to perform repeatedly, I could organize these steps into a model or create what we call a task in ArcGIS Pro. And this would enable anyone at my organization to reliably perform this workflow on new or updated data without having to be an expert user. Now that I have my hexagons, I need to do that second step. I need to summarize everything that's within each hexagon. Back in the analysis ribbon, I can use the Summarize Within tool to accomplish this. The Summarize Within tool is what's going to enable me to aggregate my data. For example, if I wanted to aggregate up by zip codes or territories, but my policy data didn't have a matching ID that enabled me to do that, I could use the geographic boundaries of those zip codes to do that with this tool. I'm going to select the hexagons I've just created as my input polygons and my policy data as the summary features. I'm going to uncheck this Keep All Input Polygons, and what that will do is limit the map to be only the polygons, in this case our hexagons, that actually have a policy point in them. I won't have any null data in my result. Lastly, I need to define what fields I'm interested in. In this case, I'm interested in the total replacement value and the total insured value. And for each of these fields, I want to know what is the sum and the average value inside each of my areas. I'm almost done when this tool completes, but once I have the aggregation, I need to perform the step where I'm finding out what are the patterns in my data. And to do that, I'm going to set up a symbology. Symbology is how I'm able to control the appearance of my geographic data, and I can do that using location or the values contained in those tables to define ranges or unique values that will alter the way I'm displaying one or more variables. And I can do so using color, size, shape, pattern, and more. I have my result now, and I'm going to turn off a few things in my map to make it a bit more clear. I'll turn off my original tessellation result, and I'm going to turn off my input policies as well. I'm also going to give this layer a bit more of a descriptive name. I'm going to call it Gulf Coast Aggregation. To set up my symbology, I need to control the way that my data appears on the map. By default, it's using a single symbol representation. There are a number of different representation methods here. The one I'm going to choose is called graduated colors, and this allows me to classify my data. I want to represent these hexagons using the sum of total insured value. And now I need to choose what method, how do I want to divide up my data. The natural breaks method is the default method used by ArcGIS Pro, and it's really popular because it enables you to quickly create a visually appealing map by varying the minimum and the maximum value of each category and ensuring that there are values within each one of those. However, since I know that Alex is going to be using this in order to make important key decisions, I'm going to want to use something that's a little bit more standardized. There are a lot of different options here, but two of them that I'll discuss today are the quantile and equal interval methods. The equal interval method divides the data up the same way that we would do if we were going to make a histogram. We tell ArcGIS Pro how many classes we want to show on the map, and the data is split evenly from the minimum and maximum value. This means that the minimum and maximum value for each class is going to be the same. However, the number of hexagons that we show in each class could vary pretty widely. So if I had 10 classes and 100 records, the difference between my minimum and maximum for each class would be the same. However, I might have a case where some of my classes could have 20 or more values in them, but others might have none at all. This would mean that some of the colors that show up in my legend don't show up in my map. The quantile method is similar to the equal interval method. However, instead of keeping the range of values the same, a quantile method makes sure that we put the same number of hexagons into each class. This means that the difference between the minimum and the maximum for each class will vary, but the count of each class will be the same. So if I was going to set up 10 classes on 100 records, there would be 10 records in each class, but the difference between the minimum and the maximum would likely not be the same. For this map, I'm going to use quantiles, and the reason is that I want to make sure that all of the colors in my legend are actually represented on the map. This way, when Alex goes to use my map, he won't be trying to find a class value that actually isn't displayed on the map. And as you can see, we've moved pretty quickly from a pretty tough to interpret array of points to something that's a bit better. However, it's still a little bit difficult to find the pattern that's occurring in this map. I'm still seeing a lot of the data in that highest class showing up in the large metro areas. There are a few more methods I could take advantage of. One of them is to increase the number of classes. I'll increase it to 10. We do want to be a little bit cautious when we increase the number of classes, because the more classes we have, the harder it can be to visually distinguish two classes on the map. Now that I have my symbology defined, though, the last thing that I need to do for Alex to be able to work with this data is share it. And I want to make sure that I'm sharing this information securely in a way that preserves the symbology that I've created, but also doesn't require me to send Alex a new file. That's because I want to make sure that Alex or anyone who's authorized to see this data is always accessing the current and up-to-date version. To do this, I'm going to share my hexagons as a web layer to our working group. Now, when I share this as a web layer, what I'm really describing is the process of sharing this to our portal. That portal can live entirely behind our firewall. I need to select how I'm sharing it. I want Alex to be able to access the raw features and define a little bit of metadata. I need to give it a summary and some tags that will make it easier to find. I can also control which groups I'm sharing to. For example, I'll share this one with our hurricane season preparations group. I can analyze this to look for any errors that might be present. And when I'm content with my layer, in order to share it, all I have to do is select Publish. The layer is posting to our portal now, and that's where Alex will be able to continue his work. And so with that, I'm going to hand this over to Alex to show us how we can carry this workflow forward to create and deploy an information product.
Oh, thank you, Russell. I'll log into the portal to access the new policy data now. And also, I see we have plenty of time left. So let me first define what the portal is. Portal is a secure data repository that enables your organization to host your data behind your firewall, but it also gives you the option to make information products public if appropriate. Here is the portal homepage for our organization. As you can see, I have various departments on the lower side of this, and also quick links to various tools if these are applications that would be used frequently within our day-to-day operations. Russell published the policy data to a group, which is just another way of keeping the data secure among only parties that need access to the data to properly execute their tasks. As you can see here, I'm a member of various groups, and this is to keep data on a need-to-know basis. So as you can see here, we have our map that we're going to be using for today to publish our information product, and now Russell's new layer has just been published here. So let's head over to the map and see what this looks like. What first sparked my initial tasking for Russell was an alert that came through one of our organization's data feed. As I zoom in, I find that there seems to be a storm starting within the Caribbean around Inagua, which has the potential to turn into a hurricane. I was able to work early on with our risk modeling team to project the path that this could potentially take. And with high probability, we were able to show that this has the potential of making landfall within Texas, sparking our need for the Gulf Coast policies. Here we bring in the Gulf Coast policies, and I've symbolized them as individual points, but faded the visualization back. Therefore, we can focus on the whole. In this particular case, we need to make a decision just in terms of general areas. Now that I have the projected path and also the location of the different policies, I can do an overlay analysis to find out what policies can be potentially affected by this storm. Now, I've already run this while Russell was doing his work, and we've also added a time-enabled step on to show when are these policies most likely to be affected by the storm. So now we know the area that the storm is likely to travel to, we know where our existing policies are, and we've isolated and identified the policies that are likely to be affected. Working again with our risk modeling team, we bring in now what their animated feed would look like. What is the path that this could potentially take based on the variables that they've studied, leveraging their expertise? What is it we could potentially be looking at so I can brief my decision makers and my stakeholders? Now, this view will look a little bit different than what you would get from the National Hurricane Alert Center. This is because this is a model that we produced to show what could be, not what has happened. But now that we know these different steps, I'm going to quickly publish out an information product to brief on these matters. So I'm hit share up in this window, and you'll see I'll have three options. First is to share this publicly. The second one is to share it within the entire organization, or to keep it within these groups, again, to keep the data on a need-to-know basis. Since there is personal identifiable information within this set, I'm going to keep it within my group, and I'm going to hit create a web application. Now I have access to dozens of pre-configured templates that don't require coding to stand up and publish live. One of the things I want to convey with this information product is a high-level overview of the insights within the tabular data sets that would be applicable, the total insured value, the total replacement value, but I want to keep and preserve the locational lens to provide deeper context. To do this, I'm going to go to the Explore and Summarize Data tab, and you can see these 6 options we have here, one of which is the time aware, in case I wanted to share out the potential model and when it could hit policies. But in this case, I'm going to do the Summary Viewer. So as you can see, I hit Create Summary Viewer, and I'll rename this now, because we do not have a name for this storm. We're going to keep it as Acme. And what this is going to do is it's going to pull from all of the web layers within that map and automatically pull the data out so I don't have to rebuild this map or recode any type of solution for it. As you can see, it's fairly clear and straightforward. We have 3 areas we can look at: general, theme, and summary viewer. The general is just what is the name of this map, and the theme is where I can change the color scheme. These are configurable. You can adjust the branding if you have particular colors in mind that you're looking for. But in this particular case, I want to make this just a clear information product, so I'm going to hit a dark gray. And then for the summary layer, I can access any of the existing web layers within my map. But since I want to brief on the affected policies, I'm going to hit the affected policies. And for my total summary, I'm going to do the total insured value as the summary field. This will aggregate all of the affected insured values to present the bottom line up front potential cost of the event. I also want to show the average so we can show any disparities within different neighborhoods if there's a presence of high value properties that are skewing the rest of the statistics. and for the minimum and max, for added context, the replacement value. I have two options. One is to display all of the policies as clusters. I'm going to turn that off because I'd like to keep the symbology that I worked on. And then I'm going to ensure that we have the type of summary ready to go. I hit save. And without coding, we now have the information product based upon the web layer that I had created earlier. So as you can see here now, we have the total count of policies, the sum of the total insured value, the average total insured value, also the replacements, the minimum and the maximum for added context. Now, this is a dynamic web layer. So as I zoom in, you can see all the numbers are adjusting. It's just giving the policies that are within that particular view. So if I go into Corpus Christi, which could be hit by the storm surge from this event, we're looking at the difference. There's a count of 64 policies, but because this is a coastal community and there are some high-value properties, we're seeing a higher value on average, higher replacement value in some areas. Whereas we now see a different picture within the Houston area. Once I hit launch, this is now a live application that I can share to anyone within our organization within this particular group. So if I was to share this link to a person outside of my organization, they would not be able to access that content because of the security procedures in place. Within the past 25 minutes, we've shown you this behind-the-scenes view of how to create these applications, the basic steps needed to quickly visualize your data, securely publish the results out through your organization, and stand up this type of viable information product. We did all this in under 25 minutes, actually, without a single line of code. I hope that this highlights, again, those 3 points. The power of using location to understand the insights that are hiding in your policy database and spreadsheets. The value of quickly sharing this information and leveraging the knowledge and expertise among your analysts. As Russell was able to pull the data from our policy databases, we had our risk modelers on another side being able to, in parallel, work to produce the what is the situation going to look like? What is the best possible picture we can give to our decision makers? So we're not just projecting a blanket $100 billion loss or $200 billion loss. So what is the most realistic picture of it? And the level of configurability. You saw the dozens of templates we can use. We can go on for days of the different data visualizations alone on this, but for now, we'll leave you with this.